Alright, hello everyone. Today I would like to teach about second oral solution of other than case. Okay, now let's move into example 3.5. So look into here, you have a circuit with voltage of 40 volts and there is a switch. At t equals to 0, the switch is closed. Remember, our notes earlier said that you need to redraw the circuit in the 3 timelines. At t less than 0, t equals to 0, and t goes to infinity. So let's move to the first step. Okay, when t is less than 0, the switch is open. So here you find your V0. Okay, V0 is the voltage across your capacitor. Okay, here you find the value is 25, while your initial current is equals to minus 0.5 ampere. All right, at the same time, let's look into the dV0 dt, since this is RLC circuit and you are solving, this is parallel RLC and you are solving the voltage. Therefore, you only need to find the dV0 dt, not the dI0 dt. So by using this equation, dV0 dt equals to minus V0 plus Ri 0 over Rc, you get the value is 0. What is the next step? Okay, the next step should be when t equal greater than 0, this is, you need to consider the circuit. Please redraw the circuit. So your alpha is 1 over 2 Rc. It gives you 500 ampere per second. Omega naught is 354. Okay, if you compare both, alpha is greater than omega naught, so this is an overdamped case. Okay, we know that overdamped case, it should give you two distinct value. So here you get minus 854 and minus 146. Now, the third step is, we know that alpha is greater than omega naught, so it is an overdamped response. So write down the general solution with S1 and S2. Right? At t equals to 0, we impose the initial condition. So here V0 equals to 25, and this is your A1 and A2. When you substitute, your t here is 0. Okay, so whenever you substitute this into 0, this becomes 1. Exponent 0 is 1, exponent 0 is 1. So it left you with only A1 plus A2, which equals to your value of V0. This is already determined at t less than 0. Okay, number 4, we find the derivative of Vt. So you differentiate this equation. Okay, differentiate your Vt, it gives you this equation. Minus 854, A1 exponent minus 854 and the rest. Right? So imposing this initial condition, we substitute the value that you have find out in step 2, where your dV0 dt is actually 0. And then this one also, exponent 0 is 1, so it left you with this equation. Okay, since you have two equations, so your A2 is actually 25 minus A1. You substitute into this and you get your A1 and A2. Okay, so finally you can solve your general solution becomes this. This is your A1 and this is your A2. Okay, let's do into the exercise. We have two exercises, so you can try this exercise. And also we have another exercise with a switch in the circuit. All right, that's all for today. So hopefully you can do the exercises. It's either you do it now or because sometimes later becomes never. Thank you.